Alright, so in this system of equations, I have x squared minus y squared is equal to 28, and x times y equals 48. So I'm given two equations. Let's just say that this is equation 1 and this is equation 2. So what I want to do is find the value of x plus y. So what is the value of x plus y? And finding this is fairly simple when we find the value of x and the value of y. So to start, what I'm actually going to do is I'm going to use my second equation here. So equation 2 is x times y equals 48. And what I'm going to do is I'm going to solve for one variable in relation to the other. So it doesn't matter which one, but for this case, I'm going to solve for y. And to solve for y, I have to isolate it, meaning I have to get rid of this x by dividing both sides by x. So I get y is equal to 48 over x. Now, using this equation, I can plug this back into equation 1. So equation 1 is x squared minus y squared is equal to 28. Now here we got y is equal to 48 over x. So if I plug this in for y, I get x squared minus 48 over x squared is equal to 28. Now I can substitute the 2, so I get x squared minus 48 squared over x squared is equal to 28. Now I'm going to multiply both sides by x squared. So now, for my left-hand side, I have to distribute the x squared. X squared times x squared is x squared squared, or x squared to the power of 2. Now I have this minus 48 squared over x squared times x squared. These two x squared cancel out, so I just get 48 squared. And now this is equal to 28x squared. Now I'm going to subtract 28x squared on both sides. So I get x squared to the power of 2 minus 28x squared minus 48 squared is equal to 0. Now I'm going to set u equal to x squared. So I get u squared minus 28u minus 48 squared is equal to 0. And now I can solve this by completing the square. So I'm going to add 48 squared back. And now I get u squared minus 28u is equal to 48 squared. Now I'm going to add this, so negative 28, or we can say just positive 28. I'm going to add this divided by 2 squared on both sides. And if you guys don't know what completing the square is, you have to go watch a video on it. So I add this on both sides. I add 28 over 2 squared on both sides. And 28 over 2 is 14, so I get u squared minus 28u plus 14 squared, which is equal to 48 squared plus, again, 14 squared. And now the reason I did this, the reason I used completing the square, was because now I can factor this out. This turns into u minus 14 squared, which is equal to 48 squared, I'm going to rewrite as 50 minus 2 squared, and 14 squared I'm going to rewrite as 10 plus 4 squared. Now from here, u minus 14 squared is equal to 2500 minus 200 plus 4 plus 100 plus 80 plus 16. And now if we add these up, we get u minus 14 squared is equal to 2500. And if we take the square root on both sides, we get u minus 14 is equal to positive or negative 50. So we get two equations. Now we get u minus 14 is equal to positive 50 and u minus 14 is equal to negative 50. So u minus 14 is equal to positive 50. I get u is equal to 64. And u minus 14 is equal to negative 50. I get u is equal to negative 36. Now remember how we let u equal x squared. So this means that x squared is equal to 64 and x squared is equal to negative 36. Well, we can't have a number squared equal to a negative number, so this is wrong, meaning that x squared equals 64 is my only proper equation, and if I take the square root on both sides, I get x is equal to positive or negative 8. So these are my two solutions to this problem. And I know that I said this wasn't work, but there actually is a way we can use this to find solutions, not real solutions, but imaginary solutions. So to do that, what I'm going to do is x squared is equal to negative 36. If I take the square root on both sides, I get x is equal to square root of negative 36. And the square root of negative 36 is the same thing as the square root of 36 times the square root of negative 1. Now the square root of negative 1 is the same thing as I, so I get x is equal to the square root of 36i. And the square root of 36 is the same thing as positive or negative 6. So I get x is equal to positive or negative 6i. So these are another two solutions. And these aren't real solutions, but these are imaginary solutions, which still count as solutions to this problem. So my four solutions are x equals 8, x equals negative 8, x is equal to 6i, and x is equal to negative 6i. Alright, so in this problem, I have x to the power of 9 plus x to the power of 6 is equal to 36. So I'm going to find the value of x here. Now, x to the power of 9, I can rewrite as x to the power of 3 times 3. And x to the power of 6, I can rewrite as x to the power of 3 times 2. So I get x to the power of 3 times 3 plus x to the power of 3 times 2 is equal to 36. Now from here, if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So x to the power of 3 times 3, that's equal to x to the power of 3 to the power of 3, and x to the power of 3 times 2, that's equal to x to the power of 3 to the power of 2. And this is equal to 36. Now I'm going to let x to the power of 3 equal to the variable t. So I get t to the power of 3 plus t squared is equal to 36. And now if I subtract 36 on both sides, I get t to the power of 3 plus t squared minus 36 is equal to 0. Now to solve an equation like this, what we have to do is first find one solution and use that solution to find the remaining solutions. And to find that one solution, we just actually have to plug in numbers and see if they work. So I'll first start with t is equal to 1. If t equals 1, I get 1 to the power of 3 plus 1 squared minus 36, which does not equal 0. If t equals 2, I get 2 to the power of 3, which is 8, plus 2 squared, which is 4, minus 36, which again does not equal 0. Now if t equals 3, I get 3 to the power of 3 plus 3 squared minus 36, which does equal 0. So t equals 3 is a solution to the equation. Now what we can do with t equals 3 is divide t to the power of 3 plus t squared minus 36 over t minus 3. And whatever equation we get from this is what we have to factor out and find the solution to. So how do we divide these two? Well, t to the power of 3 plus t squared minus 36, I can rewrite this as t to the power of 3 minus 3t squared plus 4t squared minus 36. And from here, I can factor out t squared from t to the power of 3 minus 3t squared, and 4 from 4t squared minus 36. So I get t squared times t minus 3 plus 4 times t squared minus 36. And t squared minus 36 is the same thing as t plus 6 times t minus 6. Sorry, this isn't supposed to be 36. This is supposed to be 9. So I get t plus 3 times t minus 3 is equal to 0. Now, from this whole thing, I can factor out t minus 3. So I get t minus 3 times t squared plus 4 times t plus 3, which is equal to t minus 3 times t squared plus 4t plus 12. Meaning, t to the power of 3 plus t squared minus 36 divided by t minus 3 is right here, t squared plus 4t plus 12. So now this gives me two equations. I get t minus 3 is equal to 0, and t squared plus 4t plus 12 is equal to 0. So obviously t minus 3, we already know the answer to that is t equals 3. But for t squared plus 4t plus 12 is equal to 0, to solve this, we're going to have to use the quadratic formula. So I get negative 4 plus or minus the square root of b squared, so 4 squared, which is 16, minus 4 times a, which is 1, times c, which is 12, all over 2a, so 2 times 1. And this is equal to negative 4 plus or minus the square root of 16 minus 48 over 2, which is equal to negative 4 plus or minus the square root of negative 32 over 2. And this is equal to negative 4 plus or minus the square root of 32 times the square root of negative 1 over 2. And the square root of 32 is the same thing as the square root of 16 times 2, which is the same thing as the square root of 16 times the square root of 2, which is the same thing as 4 root 2. So this is equal to negative 4 plus or minus 4 root 2, and the square root of negative 1 is the same thing as I. Now I have this over 2, and now if I divide this by 2, I get negative 2 plus or minus 2 root 2i. So t is equal to negative 2 plus or minus 2 root 2i, as well as 3. Now we're not done yet, because remember how we let x to the power of 3 equal to t. So I get x to the power of 3 is equal to 3, and x to the power of 3 is equal to this. However, we can't take the power of a number and make it have an imaginary solution, so we cannot use this solution of t. So the only solution we can use, x to the power of 3 equals 3, and if I take the cube root on both sides, I get x is equal to the cube root of 3.